our last video lesson, we're going to continue talking about probability. Two events are mutually exclusive if, that's supposed to be an if, they have no outcomes in common. So one example would be event A is drawing an ace out of a standard deck of 52 cards, and event B is drawing a face card. These have no outcomes impossible, so these two are mutually exclusive. My second example, event A is drawing a face card, and event B is drawing a spade. These do have outcomes in common. The king of spades, the queen of spades, and the jack of spades are all face cards that are spades, so they do have outcomes in common. They are not mutually exclusive. Okay, here are two statements for us. If events A and B are mutually exclusive, so they have no outcomes in common, then the probability of A union B equals the probability of A happening plus the probability of B happening. I'm not sure if this union symbol has come up before for us or if it has come up for you in the past, but it's like an or. So union is like or. So the probability of A happening or B happening is the probability of A plus the probability of B. We handled this on that little Kahoot that we did in class the other day. The very last one was something about a spinner, and it had different colors. And the last question was like the probability of landing on a yellow and a green, yellow or green, and you all took the yellow probability and the green probability and you added them together and you got 3/8. So you already handled this in class the other day. So A happening or B happening, we add together the two probabilities. And this happens when they are mutually exclusive, which means there are no instances where A and B can both happen. So this symbol here, this upside down U, this symbol that looks like this, maybe you think of the word and with the N written funny like that. So this is the intersection, union and intersection. This is the intersection symbol, or A intersect B. And so mutually exclusive, we know that there are none where A and B both happen. In my example down here on the bottom, there were some face cards that were spades. It was possible for A and B to be satisfied by the drawing of one card. It was possible to draw that queen of spades, which would be a face card and a spade. So those two were not mutually exclusive. So when two cases are not mutually exclusive, then we have a different formula. A union B is the probability of A plus the probability of B minus the probability of A intersect B. So let's take the deck of cards example. One card is selected at random from a deck of 52. What is the probability that the card is either a heart or a face card? All right, or that's union. So what's the probability that we would get a heart or, so let me do union face card. So you have to decide, are these two events mutually exclusive? So you pause and you ask yourself, is there any way for me to draw a card that would be both? And yes, we could have that Queen of Hearts. So they are not mutually exclusive. No. So we're going to choose the formula A union B equals the probability of A plus the probability of B minus the probability of A intersects B. So the probability of A happening, the first thing is A. The second event is B. Probability of A happening is how many hearts there are in a deck out of the total number of cards. The probability of B is the number of face cards in the deck over the total number of cards, and minus the probability of the number of cards that are hearts and face cards. On these, it's often better not to reduce your fractions because you get your common denominators. So 13 plus 12 minus 2, 25, minus 3. 25 minus 3 is 22 50-seconds. Now reduced by 2, and that would be our probability. Okay, here's our last scenario, or our last new thing. If A and B are independent events, that means the probability that both A and B will occur is given by this rule. The probability of A and B is the probability of A times the probability of B. An example of independent events might be rolling 2 dice and finding the probability that we roll a total of 12 with 2 6-sided dice. So the only way that can happen would be the probability of a 6 and a 6. That's the only way we can get a 12 on a 6-sided dice. So that's equal to the probability of getting a 6 times the probability of getting a 6. Well, there's 1 6 out of 6 sides on the dice. Same thing for the other one. So it's a 1 out of 36 probability. Last example, we've got a random number generator on a computer which selects 3 integers from 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? Well, the random number generator chooses a number and then chooses another number and chooses another number. So what it chooses each time is completely independent of what it'll choose the next time. So these are independent events. So we've got the probability of less than or equal to 5, and less than or equal to 5, and less than or equal to 5 occurring. We should probably call that A and B. Well, actually, these are all the same event, right? Less than or equal to 5, less than or equal to 5. So A would be the event of generating a number less than or equal to 5. So it'd be A and A and A. The probability of that happening is the probability of A times probability of A times probability of A. So that's calculated by saying, what is the probability that we get a number less than or equal to 5? There's 5 numbers in this 1 to 20, less than or equal to 5. So that's 5 out of 20 times 5 out of 20 times 5 out of 20. Or reduce it, 1/4 times a 4th times a 4th. That is 1 out of 64 chances that we would get 3 numbers that were less than or equal to 5. So that's going to wrap up this video for probability. We'll talk more about probability in class on Wednesday. All right, see you soon.